Hello, my esteemed viewers. This is Medical Science Lecturer. Today I'll be discussing with you on the resolution of word vectors. Just to inform you, I run classes for students of physics, chemistry, and mathematics. Again, I give medical tips or medical education to my esteemed viewers at the comfort of their living room. In case you are new to this channel, please hit the subscription button, turn on your notification bell so that once new videos are made, you'll be first to be notified. Again, like this video and share it if you find value. My name is Dr. Godwin Obono. Let's begin. Now, before us we have a question. This question says, find the resultant of the following system of vectors. Here we have, supposing we say this is vector A, this is vector B, vector C, and now vector D. We have four vectors, all originating from the same point, and we are asked to find the resultant of these four vectors. Now, for you to find the resultant of this vector, which of course is a common vector, now we have four of them. They want you to look for the common vector or a single vector that is equivalent to each of them in magnitude and direction. How do you go about that? Now, for you to achieve that, I want you to know that first you need to look for the component of the resultant. And for you to get the component of the resultant, you have to look for the component of each of these vectors. In other words, for every vector that is not resolved, as you can see, vector A. If I remove, for instance, vector A, let's take from vector A out of that diagram, we're going to have something like this. This is vector A. The magnitude of vector A is 2. You can see that is 2, let's say 2 Newton, and that is vector A. The angle the angle vector A made with the horizontal is 30 degrees. That is 30 degrees. Now we are asked to find, you can see that vector A is, you know that this is x-axis, this is the y-axis. Now vector A is not resolved because it is neither on the x nor on the y. So when a vector is not resolved, that vector is in between the two axes, x and y. Now for vector A, for instance, it's not resolved because it is not lying on the x, neither is it lying on the y-axis, if I may use the word lying. Now in this case, you need to now resolve vector A, meaning that you have to find the component of vector A, both horizontal component and the vertical component. And for me to do so, I will construct a line here and construct another line such that this line is equal to this line, and we can call this line, of course, if from here to here, whatever it is the same as from here to here. So if this is vector A, I may say this is AY. AY means the component of vector A vertically. I may also say let this be what AX, where AX refers to the component of vector A horizontally. For a vector to be resolved, it means you need to look for the vector, its component horizontally and its component vertically. Now for vector A, it's not resolved. It is not resolved because vector A is not found on the x-axis, neither is it found on the y-axis. Therefore, I will have to look for the value of vector A. If it has to lie on the x-axis, I will also look for the value of vector A if it has to lie on the y-axis. Now this again will take us to our trig ratios. What is the relationship between this vector, this 2 Newton and the AX? So I will say cos, if I use cos 30 degrees, cos 30 degrees will be equal to adjacent, which is AX all over the hypotenuse, which is 2. So that we have AX is equal to 2 cos 30 degrees. That means 2 cos 30 degrees becomes the component of vector A horizontally. So we need to look for the value of cos 30 degrees and then multiply it with 2. And then again, I have to look for AY. If AY, in this case, what's the relationship? I will need to use sine. That will be sine 30 degrees equal to opposite AY all over the hypotenuse 2. So that AY will be equal to 2 sine 30 degrees. So again, in this case, you need to understand one thing, that a vector, remember that when you look at the cardinal point, this is usually what? Plus x. This is plus y. Why this will be minus what? Y, and this is minus x. Therefore, it means that this x we have calculated and this y we have calculated are positive, because the a is on the positive what? Quadrant. So this will be what? Plus, and this will equally be what? Plus. So let's look for the value of 2 cos 30 degrees and see what the... So plus 2 cos 30. Remember how I got plus 2? Cos 30 is 0.8660. If you multiply that, you will have 1.732, approximately 1.73. Let's say that will be Newton. Remember, there has to be a plus sign here. Please take note, I'm putting a plus sign here. This plus sign tells you that that x component is on the positive x. As you can see, this is where the a is. A vector is here, is bounded by what? A positive x-axis and a positive y-axis. So whatever you have for x of a, in other words, ax, it has to be positive. So that's why I've written it this way. Now for the y, again, if you, of course, sine 30 is 0.5. When you multiply that, that will give you 1 Newton, and of course that will be plus 1 Newton. Now that is for the component of what? The vector a. Now you do the same for vector b. Do the same for vector b. Now this is vector b. If you remove vector b again, and then supposing we have this as the cardinal point, this is vector b. We can simply possibly say this is the vector b. This is where it is. That's vector b, and the Newton, I mean the magnitude is 2 Newton. Now this, you draw this line. Excuse. For vector b, I will remove vector b, and this is vector b. The magnitude is 2 Newton, and the angle is what? 60 degrees. This is the angle with what? The angle that is vector b made with the horizontal. And so again, I may decide to draw this line, extend this line, and this one, and you're going to have what? A right angle triangle here. So if you do that, you can now see that this will be what? The b, because this, you're dealing with vector b, so this has to be what? By, and this will be what? B what? X. What I'm saying, if you go to this diagram and then you draw a line here and draw another line here. Now if you're looking for bx, it therefore means that this will be the, of course this is always the x-axis. Therefore, if we respect to b, it has to be what? Bx. With respect to b, this is of course the vertical axis. With respect to b, it has to be what? B what? Y. That's why I've said by and then the bx. Now if you are to find the values now, the bx, of course you will be looking at what? Cos 60 degrees equal to adjacent. Of course this is opposite, this is adjacent. Adjacent will be bx all over 1, the magnitude which is 2, so that 2 Newton. So that bx will be equal to 2 cos 60 degrees. 2 cos 60 degrees. Again, if you're to look for the y, you got that will be sine 60 degrees equal to the of course 60 opposite by all over there. Hypotenuse 2 Newton. So that by will be equal to what? 2 sine 60 degrees. Again, remember that the by is and the bx are bounded by what? The positive x and the negative y. That means the component of b vertically in this case will be negative. So if you check the answer here, this answer should be sine 60. Sine 60 is 0.8660. If you multiply there, this will give you minus 1.713 Newton. If you check here, cos 60 is 0.5. If you multiply, this will give you what? 1 Newton. Again, this has to be what? Plus. Why is it plus? Because bx is the positive, we are referring to the positive x-axis. Please take note, is the positive x-axis. So we've gotten what? The bx, we've gotten what? The by. Please take note. Now let's take the next one. The next one is, if you look at this, the next is what? The vector c. The vector c. Now if you look at the vector c, again we remove vector c. Let's say that this is where the vector c is. This is your cardinal point. and this is vector C. Vector C. If I draw this one longer, and then this again, now the angle that vector C made here is 30 degrees. You draw this line, so that here will be what, CX, and this will be what, of course, if here is CX, here will be CX, here will be what, CY, and this is will equally be what, CY. So what I'm trying to say, if I'm to do this to this diagram, we are saying that this is vector C. Vector C is affected, if you can see, if you are affected by what, the x component of vector C must be negative, because this is the negative x axis. The y component of vector C must equally be what, negative, because this is what is bounded by what, the negative y axis. So at this time we will now say, let's look for what, cos 30 degrees will be equal to, cos will be adjacent all over hypotenuse. Now this is the adjacent, cx all over there. The magnitude is 20 Newton. I mean 2 Newton. That would be 2. So that Cx will be equal to 2 cos 30 degrees. 2 cos 30 degrees. And then for y, remember again, this will be what, a negative. This has to be what, negative x. That has to be negative x, because it's affected by what, the negative what axis. Now for the if you check this, 2 cos 30 degrees. Cos 30 degrees, what will be the value of cos 30 degrees? We've seen that the cos 30 degree has to be 0.6. So if you multiply this will be equal to minus 1.73 Newton. The same thing now, similarly, we have to find the value of what, the vertical component of what, the vector C. If you're looking for the vertical component, we say sine 30 degrees is equal to the opposite of that will give you what, cy all over the hypotenuse, which is 2, so that cy will be equal to 2 sine 30 degrees. Here again will be what, negative, because we are looking at the negative what, x negative y component, y axis, and so this will now give you what, 2 sine 30, and 2 sine 30 will be what, 1. That will be minus 1 Newton. Minus 1 Newton. So we can now see that we've gotten what, the x and y component of A, the x and y component of B, the x and y component of what, C. Now how about the D? How about the D? If you look at the D vector is already resolved. It's already lying on what, the x axis. You do not find it's because when the vector is in between the x and y axis, then you say the vector is not resolved, and then you look for the vectors x and y component. But for this vector D, it's already lying on the x axis, and for it to be lying on the x axis, it therefore means that dx is equal to that magnitude. In this case, the magnitude is 2. It has to be what, minus 2 Newton. Why is it minus 2 Newton? Because this axis is a negative x axis, so I have to say minus 2 Newton, meaning that that 2 Newton is lying on what, the negative x axis. Now because the D is not seen on the y axis, we now say that dy is equal to what, 0. Haven't gotten the component, all the component of each of these vectors. We've gotten the x and y component of vector A, the x and y component of vector B, x and y component of vector C, x and y component of what, vector D. And again, I told you that vector D has been resolved. That's why you see it not having any component on the y-axis, because it's already lying on the x-axis, and so the magnitude of vector D simply refers to its x component. Since it's not seen on the y component, it means it does not have any component on the y-axis, which is why we say that component has to be 0. Now at this point, we'll now be looking for the component of the resultant, the x and y component of what, the resultant. And how do we do that? We'll now say that for the resultant, for us to get the resultant, we'll say that the resultant component, the x component of the resultant has to be the sum of ax plus bx plus cx plus dx. The y component of the resultant, that's why I'm using the letter R to represent resultant, that has to be equal to ay plus by plus cy plus dy. Now let's quickly look for them. For the Rx, what is your Ax? Ax is plus, you see that it was plus 1.73 Newton, then plus the Bx. What is the value of Bx? Bx is 1 Newton. This one is also 1 Newton, plus what is Cx? The value of Cx is minus 1, okay? This is minus 1.73 Newton. What is the value of Dx? Is minus 2 plus minus 2 Newton. Okay. Now, finally, we have Rx to be equal to. This is simple. Just say 1.73 minus this, of course, that will be 0. 1 Newton minus this, that will be what? Minus 1. So we're going to have minus 1 Newton. Minus 1 Newton becomes the resultant, the x component, the horizontal component of what? Vector of the resultant. Remember, the question is find the resultant. So we are trying to look for the resultant, but for you to get the resultant, you have to first find the x and y component of the resultant. And for you to get the x and y component of the resultant, you need to equally look for the x and y component of the individual vectors so given. We have vector A given, vector B, vector C, and vector D. We have to look for each of them, their x and y component, and then you add all their x components together. That will give you the x component of the resultant. You equally add all their y components. That will give you the y component of the resultant. And that's what we have done for what? Vector what? X. I mean for the horizontal component of what? The resultant. And we got the value to be what? Minus 1 Newton. Now let's look for what? The y component. The y component, we said for the y component, what we do is to add ay. Now let's check what is ay. Ay is plus 1. Ay is plus 1. So we have what? 1 Newton plus the by. What is the value of by? By is minus 173. By is minus 1.73. And then Newton. Then we go for what? Cy. What's the value of the Cy? Cy is minus 1. Cy was it's minus 1. That will be plus minus 1 Newton. Of course, dy, we said it is what? 0. Now at this, having done this, the next thing is for us to solve it. We now say, if you check 1 Newton minus 1 Newton here will give us 0. So we'll be left with what? Minus 1.73. And so Ry will be equal to minus 1.73 Newton. So we've gotten the x and y component of what? The resultant. Now the next thing for us to do is to find the resultant. Now, what is the significance of the minus that you see? This minus tells us the direction. Supposing now, if it is minus, it tells us that this 1 Newton is on the negative x-axis. If it is minus here, it tells us that this value is, or this vector is on the negative y-axis. If this was plus, that of course will tell me that this vector is lying on the positive x-axis. So I'll quickly have a diagram. Now this diagram, if I have a cardinal point, supposing this is the cardinal point, and I'll draw this line like this. Now this is the cardinal point. Now if I extend this line, I can say that line is what? My Ry. The Ry. And if I extend this line, why am I extending this line? Because we said this is Rx. It has to be the negative x-axis. So this is the Ry. Remember that the magnitude is 1. This is the 1 Newton. Remember that this one, the magnitude is 1.73. That's 1.73. That's 1.73. Remember that this is what? As I extend that, this is Ry. And now, having done this, the next thing is to look for your resultant. I'll construct this line. I'll draw a line there. Draw a line there. If you draw this line, you draw that one also. You take this diagonal. This is the resultant. The diagonal, according to parallelogram law, this diagonal must be the diagonal, the leading diagonal, and that is what should represent what the resultant. And so with this, you can see that if here is 1 Newton, here will also be 1 Newton. This will 1 Newton. And please take note that this is an angle. This, of course, let's say this angle is theta. That is the angle the resultant makes with this line. Or you can also calculate for this angle, which of course, if I say that is alpha, that of course, while one person is calculating this, someone else may decide to calculate this angle. But whichever angle you calculate at the end, you should be able to state it, the position of that angle. Now I want to now look for the resultant. This, of course, you know that it's a right angle triangle because the angle at this point is 90 degrees. So if it's a right angle triangle, I will say that the square of the hypotenuse, which of course I'm working with this triangle, the square of the hypotenuse has to be equal to the square of the sum of the other two opposite sides. That has to be 1.73 square plus 1 Newton square. And of course, this will give us, if you find the square of that and add to this square, you should be able to have 3.9929. And now you look for the square root of 3.9929. Once you get that square root, that becomes the value of what your resultant. That will give you the angle, or sorry, that will give you the magnitude of the resultant. And if that is the magnitude of the resultant, remember that this is a vector. And if it's a vector, you must look for the direction. And so how do we get the direction? At this point, we say the direction, let the direction become by using tan theta. I want to calculate this angle. Tan theta will be equal to opposite ry all over the adjacent ry x. So by the time you now say this is equal to 1.73 all over what? 1 Newton. This is Newton. 1.73 Newton. This is 1 Newton. The Newton will cancel. You obviously will have tan theta is equal to 1.73. And now you look for what? The theta. The theta will now be arctan 1.73. So when you look for the arctan, of course, the inverse tan of 1.73, you will get an angle. That angle that you get becomes the direction of the resultant with the horizontal. Now here, don't forget, you find the square root of this, whatever you have becomes what? The magnitude of what? The resultant. That's how you find or calculate the resultant of a system of vectors where you're given, sometimes they can give you up to 520 vectors on one plane, on one cardinal point. So you look for each of the vectors, single each of them out and look for their horizontal and vertical component. At the end, all the x component, all the horizontal components should be added together and all the vertical components should equally be added together. That addition will give you the x and y component of the resultant respectively. Then you now find it using Pythagoras theory. You finally will get what? The magnitude of the resultant, and apply trig ratios or trigonometric function, you will get the angle of what? The resultant. I want to believe you have understanding of this. In case you have any problem, in case you have any comment, please drop them at the comment section. Also, do not fail to like this video. Also share if you find value. Thank you.